Greetings, I'm Medha Hira. I am working under Dr. Ravi Kiran as a SRISHTI intern at IIIT Hyderabad. So to begin with, my topic is of column detection, and this is a real problem because when you're using techniques of OCR, using OpenCV and Tesseract, what happens is that the OCR process yields inaccurate results in cases where there are multiple columns on a page. So for example, if you see the top right corner, there's a photo over here of an article of Shakespeare. So how humans read it is that we move column by column from top to bottom, and then we move to the next column. But how a model would read it would be, it would read all of the text in a synergy from left to right. It would not consider the columns. It would just consider columns as space and just move ahead and produce inaccurate results. So column detection would actually help us produce better results in documents like research papers, Lok Sabha documents, and newspapers. So to begin with, I studied the OpenCV and Tesseract libraries to gain insight into the world of computer vision. After that, I explored EasyOCR and DocTR libraries. EasyOCR was something that I found great for multilingual parsing of text, OCR texts, and DocTR was amazing for artifact detection. So the mentality with which I studied artifact detection for the DocTR library was that this would detect the artifacts, and finally I would not have to consider those in the parsing of my document. Moving on, I explored a few research papers. This was my literature review, and the research papers, although I could not find them on the topic of column detection, I did find them on locating tables, which gave me a fair idea of how to approach the topic. So over here, they were using word space and line height and developing an algorithm to detect the tables in a research paper, in a text. Moving on, this is understanding a multi-article document. So this was a paper that I found particularly interesting because, for example, what they're trying to do over here, they're trying to represent the entire document as a tree structure. And the document has an obvious hierarchical structure. So if you can see that 8H and 9B are put under the same node because it's probably the heading and 9B is the text. Further, there is 4H, and then under that we have 1H, 2B, 3H, and 3H, and 5H, 6B, 7B. So that is the structure that they've made. So 4H is probably a big line of text, a heading, and 1H and 5H are subtrees. So that was a beautiful way of understanding how document structure can be categorized, and this helped me gain further insight into the problem of column detection and ways with which I can approach it. Now, finally, this is a block detection that I found in the same paper. And over here it says, after text line extraction from an original document, image vertically adjacent text located in the same column are combined into a block. So this gave me the idea of using clustering. So this was the approach that I used. I passed through the words using OCR and I clustered them. So now what I did over here was I used k-means clustering, and I realized that this might not actually work because it was producing very haphazard results, like as you can see. And the technique even required me to set the vertical and horizontal ranges, which would make it inappropriate for classifying a bunch of documents. Like it's good for 1 or 2 documents, but if I wanted to make it a model, then this was posing as a hurdle. Moving ahead, I tried using word space and line height, as discussed in the previous research paper that I had seen. So over here, the pre-processing involved converting the image to grayscale, detecting the edges, and detecting the lines in the images based on edges. And the line height calculation and detecting the lines are processed to calculate its height by measuring the vertical distance between the starting and ending points and storing all of this in a list. Then finally, I found this library called Layout Parser. It's a unified toolkit for deep learning based document image analysis. So the paper is linked over here. Now, Layout Parser actually claims to provide an accurate layout detection with simple and clean interface. And it has a bunch of models over there. Like for example, it has PubliNet, which is generally used for research papers. And it even has a newspaper navigator, which helps us detect it helps us detect the articles, and it helps us detect advertisements. So it has a whole bunch of models under its domain, and there's intra-column reading order as well for like here I think it's Chinese text. So moving on, these are the models that Layout Parser provides us with, and this is the model that I used for my purpose. So I was able to set a custom threshold and everything, and this was a research paper that was my first demo with this model. And it provided accurate results in terms of it classified the headings, classified the text, and even the tables. So as you can see over here, this is demo 2, and this is the table that's detected, as you can see over here. And these are the lists. And there's a title detection and the words or the text detection. Now I received the feedback that to look at the method to consolidate the paragraphs, aka the text, and vertically group them together, finally forming the columns. And testing the layout parser with different different languages like Hindi. But one hiccup that I projected the layout parser might cause was the vertical grouping method may not work when a format looks something like the green boxes that I've shown over here. So this was a task that I worked on, and this was a text block that was being formed by the layout parser. It had attributes of x1, y1, x2, y2, which represented the coordinates of the box. Then, first of all, my first step was grouping all of these boxes using x1, which is my starting point. Now, this was done using the union function there, and this was the result that is presented. On the left side, the lines are a little faint, and as you can see, the columns are detected pretty neatly. Moving on, this was something that I did for Hindi as well. Now, what happened over here was that Hindi text was processed well as well, and it was detecting the columns, it was detecting a structure. The only extra thing that I had to add after doing the union over here was that there were multiple boxes that were being formed. So I checked if a box was inside another one, and I performed an operation on that. So those were basic post-processing, and this was the hiccup that I was talking about. So a document something like this. So this was a custom document that I made on Word to just see if the model works on something like this. And the only change that I had to make in the code was previously I was only considering x1s. So as I was considering x1, the entire thing was put in a box. So something like this, because there is difference between the y-axis. But then what I did was I considered x2 coordinate as well, and it worked fine after that. So this is a reference document that I'm going to show the OCR results for, basically addressing the problem statement I proposed in the beginning, that we have bad OCR results if we just use, let's say, OpenCV for it or Tesseract. In case we don't actually perform column detection, the results would be from left to right, and it would not parse the column from top to bottom and then move on to the next column. So the results are actually the 4.3 section, and these are the results that are actually produced. Now what I did over here was Tesseract, the OCR option also provides us with setting custom languages. So that is a great functionality here as well. And this was all of the work that I did at SRISHTI during my internship. And honestly, I have to say this, I got to learn a lot from my peers and from Sir, from his constant feedback. And thank you so much for letting me have the opportunity to work here at IIIT Hyderabad. I am extremely grateful for that. And this period of 2 months provided me with an opportunity to learn, grow,